Yat e shik edo shne she Lino Footracer she. Greetings, my people, my relatives, fellow educators. I'm Mr. Footracer. I currently reside in Page, but I'm originally from a little town called Lupton, Arizona. So the purpose of this video today is to learn about Bloom's taxonomy. And this is just a tool for you to use in conjunction with the modules. So there are things that we're learning in the modules, and this is just a tool on how you can take those labs or some of the material we've learned and apply it into your classroom. First, I have my Bachelor of Science from Utah State University, and I have my Master of Arts in Teaching from the University of Southern California. And I found that in my master classes, we focused on one of the areas of Bloom's taxonomy. And it's a very useful tool, not only for teachers, but for students. So let's get into today's lesson, our video. Let me pull up what we're learning here. Okay, so let me start off with slide 1. Bloom's taxonomy of learning. And let's go. Teaching native waters. Education must be increasingly concerned about the fullest development of all children and youth. And it will be the responsibility of the schools to seek learning conditions which enable each individual to reach the highest level of learning possible. Benjamin Bloom. So what is Bloom's taxonomy of learning? It was created in 1956 by Benjamin Bloom, and it eventually provided a way of categorizing educational goals. It can be used by teachers to help create curriculum, courses, lesson plans, and learning activities, as well as formative and summative assessments. So they kind of build off each other. And it also helps ensure that students have clear, measurable goals and expectations. And education, one of the hardest things to do, but one of the key foundations is to have teacher clarity, making sure our students know what they are learning. They're learning with purpose. So every day coming in, what are we doing, Mr. Footracer? Is the question that my students often ask me. What are we doing today? Well, so let's go through this, starting with an overview of the Bloom's taxonomy. We have 6 levels. First is to remember. That's level 1. Level 2, understand. 3, apply. 4, analyze. 5, evaluate. And 6, create. So 1 being the lowest level, the easiest, progressing all the way to the highest, which is to create. Let's start off with level 1. So this is kind of the beginning stage. Students need a foundation in their learning, and this is prerequisite to before they create, before they analyze, they must be able to remember. So often teachers, we engage our students by accessing prior knowledge, and we tap into their cultural knowledge. As a native indigenous person, there are different funds of knowledge that our students have, and I'm sure you encountered this in your various areas. And how do you know what is remembering? You might use words like recall, outline, describe, identify, list, or label. Some examples of remembering could be: describe the scientific method for me, identify which of the following organs is not in the circulatory system, list the levels of organization, outline the steps of your experiment. So how do we actually apply remembering in this level of learning? How do we know we're doing this in our classroom? So basically, you could have students recite during class, who can tell me the scientific method? Who remembers from 6th grade, 7th and 8th grade, what the steps of the scientific method are? Or we could have students recall, what are the layers of the atmosphere? Or does anyone remember the geological layers of the earth? And in this case, this is from my own classroom, a picture of my learning board, and I have my objectives on the top, and I have a essential question for my students to consider that day. What are the primary functions and forms of roots? And here I was teaching juniors and seniors in high school about what the different parts of the roots are and the different types, and each one specializes. For instance, taproot is very long. You have where taproot is used is in desert areas. So sometimes our students can identify those invasive species that are out competing our native species here in the Page Glen Canyon recreational area, so forth. Okay, and just because someone can remember things, we must not assume as teachers that that necessarily means they understand. So although students can recall information, they won't always be able to understand. Okay, next level learning. And this is about understanding. You could use phrases like paraphrase, explain, retell, generalize, summarize. Some examples of understanding in learning would be telling your students to paraphrase what the scientific article is about. Maybe you have a anticipatory set and you have your students coming in and they're answering their question about your warm-up. Or you can have students explain in their own words what is cellular respiration. Or perhaps you watched an educational video and you're having students summarize what they learned. And in my botany class, we had them watch a PBS video called If Plants Could Talk, or retell your elbow partner what you're doing today. So you're engaging those students, and you're making sure that they know what they're doing, they understand the directions. Okay, so some learning activities could be giving students the opportunity to do analogies. In this example here, maybe we're learning about the cell parts and its organelles. Maybe we can ask our students to find analogies to what the cell does. And if you see we have manufacturing plant, maybe that's the mitochondria, the packaging plant. There's just various structures. Lysosomes could be like the trash can. The nucleus could be the control center, and so forth. So, and we do this throughout our learning, and I think all teachers do levels of learning. And you could start very complex, or you can start very simple and go in a linear way. In education, we find that we're often cyclical and we do spiral learning. So it's okay if your process isn't from level 1 to level 6. Sometimes it moves depending on the learning situation. So the third level is applying your knowledge. So we ask learners or students to use and apply the material or skills that they have been studying, taking what they learned about cellular respiration and applying it on words that cue us into this type of learning would be use or solve, show, predict, apply, demonstrate. So if we're doing a unit on global warming, we could have our students, what do you predict the future climate would be like in the year 2050? How about 100 years from now? what are the implications? So here are some examples. You could do a chemical reaction, or perhaps you can have predict the products of the chemical reactions, demonstrate a proper lab safety rules. After the beginning of the year, I'll have my students go over lab safety rules, and I'll observe them and I evaluate them on their performance, and I'll correct them or have their peers. So it's always pretty fun to see it. So again, it could be solving an equation, applying what they learn. In this case, we're talking about calculating joules and how much heat is needed. And you have your basic MCAT equation, and you can guide your students. You can see their process, their learning. This has other applications too. It could be making phone calls or completing a form. The assessment could mirror that real life activity, could focus on knowledge such as a math formula. You might ask learners to make calculations based on their understanding of the formula, so forth. All right, level 4. So we're starting to go up on the line here. This is analyzing. It's assessing whether students can draw connections between ideas and utilize their critical thinking skills. So this is where we want our students to be critical learners, critical thinkers. But as educators, we know that this is an area where we struggle in. You know, it may need guiding. You need to scaffold their learning to be able to infer, to deconstruct, to differentiate, compare, to analyze. And often I find that having taught 6th grade and 12th grade, the ability for students to do this on their own varies with their developmental age, so forth. So an example of this could be compare cellular respiration in plants to cellular respiration in animals. How are they similar? How are they different? We can talk about anaerobic, aerobic, fermentation in fungi. You know, there's a lot of different applications. And by you as a teacher, when you do a Venn diagram, this is an example of analyzing how are plants and animal cells different from each other, how are they similar? It's like compare and contrast. It's not always a type of question. It could be done in multiple formats too. And asking a student to differentiate, these are good essay questions. The type of assessments that I use can tell whether the students have understood the knowledge and they're getting the lesson, or if I need to go back and reteach this. So analyzing is a very critical step in the levels of learning. The types of activities you can do with analyzing: you can have students find fallacies. You can give them scenarios, break them up into groups, and have them identify what is wrong with the experiment or what makes this problem wrong. You have them justify. It says also they have to use logical deductions to determine how a particular piece of equipment works. These tasks allow the students to demonstrate that they understand the material fully and can break it down into its component parts. Often we do group projects. We can do Google Slides, or we can have them do a gallery walk or a mini poster or large butcher paper. So there are many ways of getting your students to analyze the material. All right, level 5. This is with students who reach this level are doing assessing whether students can differentiate between facts, opinions, and inferences. So at this point in their learning, they should know what is a fact, what's an opinion, what's an inference. We could use words like critique, evaluate, appraise, conclude. We could give them a false claim and tell students to identify if it's right or wrong. So have students appraise their group's experiment. A general appraisal may evaluate the measured outcomes, sample sizes, reliability of the data, the implications for the research, applying what they learn, and maybe possible changes to the experiment if repeated. If would they do anything different? All right, the evaluating, you may ask students to find fallacies in their arguments. Oh, sorry, just went over that. Okay, next level, creating. The highest level of learning in Bloom's taxonomy is asking the learner to create something either tangible or conceptual. And I don't know how the standards are in your particular area, but here in Arizona, we recently have had a makeover of all our standards, and they're shifting towards phenomena, being able to interact with a phenomena, creating models, whether a physical model or it could be digital. There are a lot of different ways of engaging learners. So it's more not just rote vocabulary memorization, but we're really trying to shift our focus of teaching our students to be critical thinkers and become students of science, and how they can design their own experiments and demonstrate that they know the principles that they've learned in the unit. So types of learning that give us clues that it's level 6 would be to write, to generate, to design, combine, devise, or modify. Some examples that I would give to my most gifted students, or maybe in a formative assessment, I would be design your own experiment, conduct research and write a report, devise your own unique solution that addresses global warming. So this level of learning is very complex, and without the smaller components, they wouldn't be able to get to this step. Some examples of creating would be, if the learning is practical in nature, you may ask learners to design a product or physical device such as a piece of machinery. In my case, maybe we're challenging them for global warming. So what are some devices that students can create to address climate change or pollution in our area? If the learning is conceptual or intangible, a suitable learning activity may be writing a report or creating a manual or writing an essay or paper. In my case, I use Google Classroom, and I'll have students create Google Slides, and maybe they do a mini presentation, a gallery walk, and we do a rubric to assess that learning. This is the highest level of learning. So aside from, those are all the levels of learning in Bloom's taxonomy. Now, what's the catch here? Why am I sharing this with you? And the reason for this is that it introduces rigor, and it also helps engage our students. It's not only a useful tool for teachers in designing lessons, but it's also a useful tool for learners, for the student. And some of the things that I do as a teacher is I might ask my students who get done early to go back through and identify the type of learning. So is this a level 1? Is this level 3? Is this level 6? Sometimes it's not just my gifted students that get this too. I'll present in my lesson. I might pause for a moment, and I might have my students reflect on their own learning experience and share with me what they think this is. And you can do a simple classroom survey with your hands. Is this a level 6? Is this creating? Is this a level 4, analyzing? Is this a level 1, or recalling information, remembering? So it's very helpful for students to do that metacognition And over time, as students become aware of their learning, they begin to see these connections, these cross-cutting concepts from maybe their middle school learning experience all the way to their high school. And not only in science, but they might see these cross-cutting concepts also applying to social studies or to English or to math. And that's what we want, is a well-rounded student to be continually thinking about their learning. So in a nutshell, this is Bloom's taxonomy, and I will share with you guys in my teacher toolbox this PowerPoint. I'll also give you some handouts that you can share with your students. I did attend AVID training, so you'll see a lot of AVID worksheets in there, and it's just a wonderful tool and way to get our students to engage with the material. And I hope this little bit gave you a nice overview of what is Bloom's taxonomy. Thank you. Okay, so all right. Well, that concludes our segment. So we just learned a little bit about the 6 levels of Bloom's taxonomy, going from remembering all the way up to creating. Thank you.